All right, so we're still revolving around the x-axis. So in general idea to find the surface area is going to be 2 pi radius, which will be y, times the arc length. So before we used y as f of x. This time we're going to keep the y and then use dy. So it's going to feel a little bit odd. All right, here we go. So it's going to give you limits of integration in y's, and you'll get a function that'll be x's in terms of y. That will cue you in to do the surface area with this equation. So let's first find dx over dy. So that's 1/3 y to the negative 2/3. So then we're just going to keep y as the radius, because that's the radius if I'm revolving it around the x-axis. Square root of 1 plus, so I'll have 1/3 y to the 2/3 squared dy. And then from 1 until 4. All right, so I have 1 plus, and if I'm squaring this, remember you multiply the exponents, right? So I get y to the 4/3 power, multiplying exponents. So here on this one, it's very different than the last one. I'm going to make common denominators between these two terms. So I'll have 9y to the 4/3 plus 1 over 9y to the 4/3. All dy. Okay, so other facts that we know about radicals. If I have radical of a over b, that's the same thing as saying radical of a over radical of b. All right, so I'm going to do that here. So I have root on the top, and on the bottom. Okay, so now I haven't put the limits of integration in 1 to 4. Okay, so now I'm going to take the square root. I'm going to keep this up here in the same. Now I'm going to take, if I think about what taking the radical of this would be, so it's like saying root 9 and then root y to the 4/3. So this gives me 3. This is like saying y to the 4/3 to the 1/2 power. And so I multiply exponents, so I get y to the 2/3. So this simplifies to y to the 2/3 in the denominator. All right, so now I'm going to simplify exponents. So this is y to the 1 power. I'm going to subtract off the 2/3, so I get y to the 1/3. And then this 3 here, I'm going to pull it outside. So then I get this still. dy. All right, now an easy u substitution will work. That took a little while, didn't it? Easy u, du, 9 times 4/3, y to the 1/3. 3 cancels, so I've got 12 here, so 1/12 du is y to the 1/3 dy. So here's my 2/3 pi times another 1/12 u to the 1/2 du. So this gives me pi over 18. Take the antiderivative. 2/3. I lost my limits of integration again between 1 and 4. So if I put 1 in here, I get 10. So let me write down. So if I have y equal 4 and I'm putting it into here, so I have, yeah, this is going to be an ugly number. Okay, so 9, 4 to the 4/3 plus 1. All right. So from here, I get pi over 27. So I'll have 9, 4 to the 4/3 plus 1, all to the 3/2 power minus 10 to the 3/2 power. And that is the arc length.